Have you ever felt like indices is difficult? Well, watch this video to the end, and I know you will be halfway into saying indices is one of the simplest topics that you will ever solve. And then watch successive videos, and definitely, I can bet you become a guru when it comes to indices. The key to indices is all about remembering the laws, as I have stated in the previous video, and then being able to know that the laws goes both ways. So it all depends on what favors you at a particular time. Once you know this, then you are well on your way. Let's begin with the first one. Basically, you see that the power is fraction. So what does that mean? The denominator becomes a root and the numerator remains a power. That simply means this is going to become 2 becomes a square root of 36 over 25, and the numerator remains a power. Now you know when 1 is a power, it makes no difference. So we can basically skip the 1 as the power. Whenever we have a root like this over a fraction, it affects both the numerator and it affects the denominator. That simply means the square root of 36 over the square root of 25. And this gives us square root of 36, that is 6, square root of 25, that is 5. So we have 6 over 5, or 1 whole number, 1 over 5. And that is all. Next question. 32 over 50 raised to the power of minus 1.5. First thing we do, you remember whenever you have a negative index, what do? If it's a fraction, simply turn the fraction upside down. That means in this case, we'll be having 50 over 32. Turn the fraction upside down, then the negative power disappears, raised to power 1.5. Now with 1.5, there's practically nothing we can do in this case. So all we simply have to do is, we have to convert 1.5 to a fraction. For those who are familiar with this, you know it is 3 over 2. So you simply go ahead and say 3 over 2. But for those who don't know how to do this, let's take out a small section and do it. 1.5. We want to convert to a fraction. What you do is, first of all, ignore the decimal. Then write the number. What do you have? You have 15. When you ignore the decimal, all over 1. So ignore the decimal, write the number, and say all over 1. Then the next thing is, how many numbers are after the decimal point? If it's one number, you add 0 to the 1, which you brought up. If it's 2 numbers, you add 2 zeros. So in this case, it is only one number, which is 5, after the decimal point. So we simply add a single 0 to the 1. That means that 1.5 is the same thing as 15 over 10. From here, we simplify. 5 divided 15 is 3. 5 divided 10 is 2. That means that 1.5 is 3 over 2. So we simply can write this now as 50 over 32 raised to the power of 3 over 2. Now it is exactly like our fractional index. What do? The denominator becomes a root. That means 2 becomes a square root. And then the numerator remains a power. So we are simply going to have square root of 50 over 32 raised to the power of the numerator, which is 3. Now, if you observe this, 50 and 32, they don't have a square root. And people will feel like, oh, this is the end. That is not the end. Whenever you have numbers, a fraction basically, inside a square root, and the two numbers, they are not perfect squares. That means the numbers don't have square roots. You basically just simplify the numbers. So when we have 50 over 32, we simplify. 2 divided 50 is 25. 2 divided 32 is 16. So you simplify it until you have numbers that have square roots or that are perfect squares. So that's the same thing as the square root of 25 having simplified over 16 raised to the power of 3. As I've already said, the square root affects both the numerator and denominator. So we take the square root of 25, that gives us 5. And we take the square root of 16, that gives us 4. Now it is still raised to the power of 3, which is the power outside. And again, in this case, because there's a bracket, the power affects both the numerator and denominator. So we have 5 raised to the power 3 over 4 raised to the power 3. 5 raised to the power 3 means 5 times 5 times 5. That is 125. Divided by 4 raised to the power 3. 4 times 4 times 4. And that should give us 64. So this is our answer. Then again, this is an improper fraction. So you can decide to say, oh, I want to convert it to a mixed number. 64 divided by 125 can only go once, because 64 times 2 is 128. So it can only go once. And our remainder is 61. So you can leave it as 125 over 64, or you can take it to become one whole number, 61 over 64. This corner is for rough work, so let's separate it out. Now the next one. 2y raised to the power half times 4y raised to the power minus 2.5. In this case, what you simply do, you can see that you are having the same base. So don't start thinking yet of doing, oh, because y is a negative index, you make it become 1 over. You can do that, but it takes an extra step away from you. So the first thing you simply do, because they are the same base, try to solve them as indices. Now 2 and 4, they are just regular numbers. So we do our regular multiplication. Remember, the law of indices applies only when you have the same base. So in one place, we put the numbers, and in the other place, we put the alphabets which have the same base. 1 over 2 times y raised to the power minus 2.5. Simply take the numbers in one place and take the alphabets in one place. Alphabets which have the same base. So now these are regular numbers. You can simply do your straightforward multiplication. 2 times 4 gives you 8. So we are done with this one. Next, we have to solve this. But first of all, we are going to have y raised to the power half times y. Again, you have two ways to do this because it's practically the same base. You can convert 1 over 2 to decimal, that gives you 0.5, and you move on from there. However, because I'm trying to practice using fractions, let us use fractions. So 2 over 5 or 2.5, convert it to decimal, same step applies. Ignore the decimal, that's 25, make it over 1. Only one number after the decimal, so you add a single 0. Simplify, 5 divided 25, 5. 5 divided 10, 2. So 2.5 is the same thing as 5 over 2. That is minus 5 over 2. Again, we are done with 8, so we put 8. Now, the base here is y, the base here is y, and we are multiplying, so we can pick one base. The first power is 1 over 2. Now, this is where you have to be very careful. The first power is 1 over 2, so you take your 1 over 2. Remember, when you are multiplying, that means you are going to add the powers. Simply put, times will become plus. And then the next power is minus 5 over 2. So there you go. So then you have 8y raised to power. Whenever two signs are standing side by side, you multiply them. So you have 1 over 2. Let me write it properly. 1 over 2. Plus times minus is minus 5 over 2. And then this gives us 1 over 2 minus 5 over 2. Again, you are familiar with the practice of fractions. which says when you have the same denominator, simply pick one. And if you are subtracting, just subtract the numerators. So the denominator is the same, 2, 2, just pick one. And then we say 1 minus 5. That gives us minus 4. When we simplify, 2 can divide 4. 2 here is 1, and 2 here is 2. That means we have 8y raised to power minus 2. Now, this can be our final answer, but it is not. Because remember, in your answers, it is not standard to have negative indexes. Whenever you have negative index, what do? Make it become 1 over. But now you have to observe very carefully. This minus 2 is affecting only y. It does not affect 8. So that simply means that it is only this y that becomes 1 over. The 8 does not become 1 over, or it's not inverted. I think that's a better language. So we are going to be having 8 times, because of the negative index, it becomes 1 over y raised to power 2. So simply make it over 1 because it's a fraction, and then we'll multiply. 8 times 1 is 8 over 1 times y squared is y squared. So our answer is 8 over y squared. So it's quite simple. Take the numbers to one side, take the alphabets to one side, the same base. Follow your law of indices, and then you arrive at this point. But always remember, check what the negative power is affecting. In this case, this negative power belongs only to y, so therefore it's going to affect only y. It will not affect it. All right, for question number 4, let's create a demarcation. Now this looks complex, but it's quite simple. Now, you can see the point you are making. You turn it to what is going to favor you. Now, if you observe, I cannot from here turn, because you can solve it in different ways anyways, but the easiest way is the way we should be looking at. So first thing you can easily do, you can say, oh, because the power is negative, make it become 1 over. So you're going to be having square root of 1 over 216 raised to power 2 over 3. And then the denominator becomes a root. You solve that, and you continue to move on. You can do it like that. However, a shorter way is, you remember, how do you get square root? You get a square root when the power is a fraction. So that means that if I have a raised to power 1 over 2, it becomes square root of a. So that means that this square root here is coming from it being raised to power 1 over 2. So I can simply say this thing is the same thing as 216 raised to power minus 2 over 3 times this square root. I want to make it become an index. I want to reverse it to become an index. And if I reverse square root to become an index, it becomes 1 over 2. So I make it become 1 over 2. So then I have 216. When you multiply this, let's save a bit of time, because I'm trying to solve it in 2 ways. When you multiply minus 2 over 3 times 1 over 2, you see that 2 cancels 2. So you simply have minus 1 over 3. So here I'm going to have minus 1 over 3. Now you can follow your negative index. Because it's negative, make it become 1 over 216. Well, 216 is the only number inside, so you can simply take away the brackets, and it becomes 1 over 3. And now, you have a number raised to power a negative index. That denominator becomes a root. This time is 3, so it becomes cube root. So you're going to have 1 over the cube root of 216. Again, raised to power 1 will make no difference. So simply leave it at that. So you are going to have 1 over cube root of 216. That should be 6. So our answer is 1 over 6. So that is one method. However, what if I want to solve it some other way? Same question. Let me say or. I always tell people there are different ways to kill a rat or catch a rat. Depends on your choice. So you have 216 raised to the power minus 2 over 3. So somebody else can say, okay, I don't want to invert the root yet. I want to solve what is inside. This is practically looking like board mass. I want to solve what is inside the root. When I'm done, I can take care of the root. So what that simply means is that the person is going to be solving 216 raised to the power of minus 2 over 3. So what does that become? You have square roots. Your negative index means you turn the number or you invert the number. So it becomes 1 over 216. Again, 216 is the only number inside the bracket, so you can basically remove it. 2 over 3. So you can say I want to solve the square root last. So then I continue to have my square roots. 1 over, whenever I have a square root, what happens? The denominator becomes a root and the numerator remains a power. So I'm going to have cube root. You can see this remains my outer square root. Cube root of 216 squared. We go on. So then we have square root of 1 over cube root of 216 is 6. So we have 6 squared. So we are going to be having the square root of 1 over 6 squared is 36. And you remember, whenever we have a square root, what happens? It affects both the numerator and the denominator. Again, let's save time. So it simply becomes square root of 1 is 1 over square root of 36 is 6. So you see, you get exactly the same answer as you have gotten here. So it's all about looking at the question and you know exactly how to go about it. There are different ways, like I said earlier, to catch a rat. Now, in this case, this is a decimal point. So the question becomes, what do I do? Well, again, as I'll be doing earlier, if you have a decimal, convert it to a whole number. So 0.0064. 0.0064. First thing you do is what? Ignore the decimal point. So you write it 0.0064 over 1. How many numbers after the decimal point? 1, 2, 3, 4. You have 4 numbers. 1, 2, 3, 4. And there you have it. So now whenever 0 comes before a number, those zeros can be eliminated. So you simply have 64 over 10,000. So you simply come to this place and replace. So you have 64 over 10,000 all raised to the power of 2 over 3. So you can see it is just that straightforward. Oh, it should be 10,000, not 1,000. All right, so up next, you have a fractional index. The denominator becomes a root and the numerator remains a power. So you are going to be having the cube root of 64 over 10,000 all still squared. Now, if you should check it out, 10,000 when simplified does not give us, or does not have a cube root. So what do? Remember what we did earlier. When there was no square root for some numbers, we simplified. If we check it out, 64 has a cube root, which is 4. But we need both numbers to have a cube root, because most times in indices, you need whole numbers. So we simply have to simplify. So check it out and divide. So let's see, if you divide 64 by 10,000, 2 divided 64 is 32. 2 divided 10,000 is 5,000. Then again, 32 does not have a cube root, so we'll continue. 16, and this is 2,500. Divide 16 is 8, and this is 1,250. So we are simply going to have the cube root of 8 over 1,250. Again, if you observe, 1,250 does not even have a cube root. So practically, what do? We get only the cube root of 8. Cube root of 8, that's the number you multiply 3 times. Square root means what you multiply twice. Cube root means what you multiply 3 times. What you multiply 3 times will give you 8, and that is 2. Over 1,250 does not have a cube root, so the cube root remains there. Over 1,250, all squared. So I guess you can stop here, or you can say, okay, the square affects what is inside the square roots. So what is inside the bracket, sorry? So 2 square gives you 4 over, you couldn't get the cube root of 1,250. So you leave it like that, and it will still be squared. So this is your answer. So I guess the question is actually 40. Possibly the question should have been 0.064. If there's 0.064, then we have 1,000, and 1,000 has a cube root. However, this is the question we had, and this is the question we solved. We will not assume that this is what they wanted to give to us. So this is indices. Watch out for the next video where we dive deeper and have even much more complex examples.